Okay, we are live on YouTube.
Okay.
And yes, your screen is visible, ma'am.
Yeah.
Okay. Good morning, one and all. On this auspicious day, am I audible, ma'am?
Yes, yes, sir. Yes, sir. You can
Okay.
proceed.
Good morning, one and all. I am very happy today that on behalf of Microbiology Society of India, we are continuing our PhD webinar series. And today we have our speaker number 23, Dr. Mangala Lakshmi Raghavan. Ma'am will today speak of unraveling the efficacy of probiotic yeast isolated from various sources. And I would like to mention one more thing. In this PhD webinar series, we are giving memento and certificate to each and every speaker. I make an appeal to all of you, all the people who are listening on YouTube as well as live, that if you know any PhD students who have completed their PhD in last 4 or 5 years, please ask them to get in touch with us so we can invite them for this lecture series. And I invite Dr. Lakshmi ma'am to start her lecture. Ma'am, please.
Yeah. Good morning to one and all. Gather here. I'm Mangala Lakshmi. I completed a PhD in biomedical sciences in VIT Vellore last year, like 2021. But I got a degree in this year, 2022. I'm here to present my part of PhD work here in the PhD webinar series, which is organized by Microbiology Society. The topic is unraveling the efficacy of probiotic yeast isolated from various sources. As we know, probiotics are live microorganism which is employed as food supplements to benefit the health for human as well as animals. It has three beneficial functions, namely colonization resistance, immunomodulation, and nutritional contribution. Over the past decade, we have seen many bacterial strains which has been characterized as a probiotics. In case of yeast, only one strain has been commercialized so far, which is Saccharomyces boulardii. In another case, live Saccharomyces cerevisiae cells are employed as a biotherapeutic agent to treat chronic or recurrent diarrhea, which is especially associated with Clostridium difficile strain. Therefore, the present research aims to isolate, screen, and identify new yeast strains from various sources to characterize their role as a potential probiotics under in vitro and in vivo conditions. This slide shows most common microorganism which is studied for probiotic properties. And here also we can see many strains belong to bacteria like Lactobacillus, Bifidobacterium, and other bacteria like Streptococcus, Escherichia coli. In case of fungi and yeast, only few strains have been identified as a probiotics. I have chosen probiotic yeast because it has many advantages over bacteria. Especially, it continue work in during antibiotic usage, and it reaches colon in active stage. Also, it appropriate for all age of people. When it compared to bacteria, restrict the age for people. Also, it withstand the harsh environment in the GIT, and it stimulate the immunoglobulin A production in the intestinal. Whereas in probiotic bacteria, it is less producible. This slide shows application of probiotics. It has wide range of applications. To improve the plant health, it has been used as a biofertilizer, biostimulant, biopesticides. In case of animal health, it has been used as animal feed for improving a broiler performance and some aquaculture performance. To improve the human health, it has been incorporated into fermented food products, fermented vegetable, fruits, as well as fermented cereals to improve the health benefits in the humans. In India, this slide shows the status of probiotic research in India and the products which have been used in India. And these are all some of the research centers which are actively involved in the probiotic research in India, as well as some of the product which has been produced by Indian-based companies, and I've listed the products here. And the Indian probiotic industry is infancy stage. In all over the world, we can say 1% of total market is turnover probiotic industries belongs to India. I have listed some of the commercial probiotic supplements here, like Protaxin, Lactina, Bovin 14, which have been used for improving the broiler performance, as well as some of the animals, and have been used as a growth promoters. I have made some objectives in my study, starting with objective 1, which is isolation, preliminary screening, and molecular identification of probiotic yeast isolates. I have collected samples from different sources like fruits, vegetables, plants, meats, insects, as well as industrial effluents. I have collected around 20 samples. From that, I have isolated 20 yeast strains, and I have done the spread plate method to observe the colony morphology under microscope, and I have given the colony morphology for all the isolates here. And this slide shows the microscopic examination of pure cultures of yeast isolates, which have been isolated from different sources. Here we have done the simple staining for the yeast, and the stick plate and spread plates I have given here. Coming to the preliminary screening, as we know, probiotics or lives in the gut region. The gut region environment should be optimum for the probiotic strain. It's a prerequisite for the probiotic. It should survive under the gut conditions. So as we know, we have a gut condition is extremely acidic condition. So I have adjusted the YPD media with different range of acidic conditions using acid agent, and the extremic acidic condition is the optimum condition for the probiotic strains. So here I have highlighted the PST2 for all the yeast isolates, and some of the strains showed a better growth at PST2 adjusted YPD media. Coming to the thermotolerance, I have taken different ranges of temperature to see the growth. For optimum temperature of our gut region is 35 degrees Celsius plus or minus 2, and many of the strains showed better growth at 35 degrees Celsius compared to the 45 degrees Celsius. For bile salt tolerance assay, I have inoculated all the yeast isolates in YPD media, which has a different range of alcohol concentration starting from 0.2% to 1.5%. According to the literature review, 0.6% will be the optimum condition for the probiotic strains, and I have highlighted the same concentration for here. And many of the strains showed better growth at 0.6% of bile salt concentration YPD media. Another preliminary screening is antibiotic susceptibility test and antimicrobial activity test. Yes.
Hello.
Yes.
Hello, ma'am.
Yes, yes, sir. Hello.
Hello.
Yes, sir. It is audible.
So sorry to interrupt you, ma'am. There was some connection issue, I guess.
1 minute. It's audio or video?
Audio. Now you continue. It is fine.
Okay.
Please continue.
Okay. Preliminary screening also includes antibiotic susceptibility test and antimicrobial activity. For antibiotic susceptibility test, I have taken wide range of antibiotics, and I have shortlisted some of the strains from this preliminary screening. Around 9 strains I have shortlisted for further studies. In the antibiotic susceptibility test, among the 9, only 5 isolates, namely LM, MR, GI, GI2, and WI showed significant results against antibiotic susceptibility test. In case of antimicrobial activity, I have chosen 5 pathogenic strains, Pseudomonas, Klebsiella, Bacillus, E. coli, and Staphylococcus, and I have treated with the yeast isolates. The antimicrobial activity was significant among these 5 strains compared to other yeast strains. Further, I have done the molecular identification for the screened probiotic yeast strains, and the sequencing was done, and the sequences was submitted to the NCBI database, and the accession number was given here. And the LM strain was named as Erevia lipolytica, and MR strain belongs to Chloromyces lactis, UI strain belongs to Lipomyces starkei, GI2 belongs to Saccharomyces fibrosura, WI belongs to Brettanomyces crustaceanus. We have named Erevia lipolytica VITMN01, Chloromyces lactis VITMN02, Lipomyces starkei VITMN03, Saccharomyces fibrosura VITMN03, and Brettanomyces crustaceanus VITMN05. And this the constructed phylogenetic tree was given here for all the 5 probiotic yeast strains. Coming to the objective 2, evaluation of novel characteristics of screened probiotic strains. These are all the novel characteristic feature for probiotic strains. We are going to see in further slides. The novel characteristics start with the aggregation ability of the probiotic strain. The aggregation ability is an important criteria for the probiotic strain. The auto-aggregation ability was assessed for all the 5 probiotic yeast. Among the 5, Lipomyces showed the maximum auto-aggregation ability around 92% compared to other probiotic yeast strain. Co-aggregation ability also assessed for all the yeast strains with against pathogenic bacteria like Salmonella and Klebsiella. In this figure, I showed co-aggregation ability of probiotic yeast against Salmonella. And here also we found lipomyces followed by Saccharomyces fluorida showed the maximum co-aggregation ability around 96%. In case of Klebsiella, lipomyces starkei showed 98% co-aggregation ability followed by Saccharomyces fluorida. The cell surface hydrophobicity was also assessed using 3 hydrocarbons like chloroform, N-hexadecan, and diethyl ether. And among the three, N-hexadecan showed the maximum cell surface hydrophobicity in all the probiotic yeast strains. Especially the Lipomyces starkei showed the maximum cell surface hydrophobicity, followed by Saccharomyces fluorida. Other potential properties is GIT tolerance. Probiotic bacteria should survive under the GIT conditions, as I said earlier. The simulated GIT environment were made in the YPD media using the literature review of some many reports. And here we have shown the results for all the 5 probiotic yeast strains at a different time interval. And here we can see the GIT tolerance was significantly significantly improved in the Lipomyces starkei, Saccharomyces fluorida at different time intervals. In the cholesterol assimilation assay, I have used 100 mg of cholesterol, which is inoculated in the IPD with the probiotic yeast, and I have assessed the assimilation rate at different time intervals starting from 4 hours to 48 hours. The maximum assimilation was occurred 24th hour compared to 48th hour in all the probiotic yeast strains. Especially Lipomyces starkei and Saccharomyces fluorida showed the maximum cholesterol assimilation rate, which is above 80%. The adhesion ability of Lipomyces starkei was assessed on the COCO2 cell line, and the in vitro assay was performed. The colony forming units were assessed after the adhesion assay. It was 88% adhesion ability was observed on COCO2 cell line for Lipomyces starkei V80MN03. The another novel characteristic feature of probiotic is production of some beneficial compounds like antimicrobial proteins and exopolysaccharides and other compounds like vitamins and short chain fatty acids. Here I have assessed exopolysaccharide production by the probiotic yeast, especially Lipomyces starkei I have done. And this is the methodology I have used for the exopolysaccharide production by the probiotic yeast. The special, I have inoculated the probiotic yeast in the special media. Then I have extracted the exopolysaccharide using solvent extraction method, and I have purified the EPS using a dialysis membrane, and I have lyophilized the EPS for the further characterization. Exopolysaccharide production was initially started for all the 5 probiotic strains, but we noticed Lipomyces starkei was found to produce more EPS secretion. So further, we have chosen Lipomyces starkei for the exopolysaccharide production, and here we have shown the viscosity for all the EPS which is secreted by probiotic yeast strains like Lipomyces, Cleveromyces, and Crestonceus and Saccharomyces and Unravelling epileptica. And the same analysis also performed for the Lipomyces starkei strain. And here we can see the exopolysaccharide secretion on the yeast cell surface, and this is the polysaccharide surface on this under SEM. Characterization was done for the purified EPS, HPLC, FTR, GC, and XRD analysis. In the HPLC analysis, we found the presence of the following sugars: arabinose, ribose, galactose, glucose, xylose, rhamnose, mannose, according to the reference standard peaks. And the GC analysis also, we found the presence of many sugars. Especially, we found the peak for fucose, because fucose is having a potential application in the medical field as an anti-cancer, anti-inflammatory agent, as well as it's a cosmeceutical skin moisturizing agent, which has many beneficial applications in it. And the FTR analysis also, we found the presence of carboxylic bond and beta glucosidic bond and other carboxylic structures and other CO structures. In the XID analysis, we found the EPS was partially crystalline around 67%. NMR analysis also done for the EPS produced by Lipomyces starkei. In H1 NMR spectrum, we found presence of beta glucose, alpha rhamnose, and alpha mannose peaks in the anomeric region. In the C13 NMR spectrum also, we found the peaks which corresponded to alpha rhamnose, alpha glucose, alpha mannose, and beta glucose compounds. Hence, we conclude that heteropolysaccharide composition of EPS was constituted by alpha 123, 122 linked to rhamnone, alpha 126 linked to mannone, alpha and beta 123 linked to glucose. The applications of EPS also assessed in this study. We have done the biosurfactant activity with the oil dropped test. Here we can see, here we dropped custard oil after pipetted EPS solution in the oil surface. We can see the clear zone formation. This is just an initial qualitative analysis for the biosurfactant activity assess test. And further, we have done the surfactant activity using a different concentration of EPS, and where we have used xanthan gum as a positive control. It is already commercialized exopolysaccharide available in the market. And here we can see it shows the significant results like surfactant activity around 82% compared to the xanthan gum, which shows 79% activity. In case of antioxidant activity, we have done different assays like total antioxidant activity, DPP scavenging activity, hydroxyl radical scavenging, and reducing power. Here we have used ascorbic acid as a standard. And here also we can see significant antioxidant activity in terms of DPPH as well as hydroxyl radical scavenging activity compared to ascorbic acid. In case of total antioxidant reducing, in case of total antioxidant, ascorbic acid showed the maximum antioxidant activity. Further, we have done the EPS for the mutagen binding ability using different chemical mutagens like GLUP1 and MUQI and agridine orange. And we have done the binding ability around 30 minutes and 60 minutes, and maximum binding ability was found to be more in after 60th minute in all the mutagens. Coming to objective 3, encapsulation of probiotic yeast for easy gastrointestinal transit. And this is the methodology we have used for microencapsulation of probiotic yeast. We have taken the alginate as a base material, and we have added the core material, like which we have chosen some of the food sources. With that, we have inoculated the yeast, then we treated, then the microcapsules were produced. The preliminary screening was selection of encapsulation material we have done. I have chosen different brand material like rice bran, oats bran, barley bran, finger millet bran, pearl millet bran. Based on the composition of the gum extracted from the different respective cereal brands, we have seen the potential bran will be a oats bran, which has a more carbohydrate, protein, dietary fiber, beta glucane content in it. And the encapsulation efficiency for all the material were assessed for probiotic yeast, and we found the resistant starch will be the maximum, showed the maximum encapsulation efficiency around 85, above 80%. In terms of swelling behavior studies, also we found resistant starch will be the least in size compared to other encapsulation material. And here shown the encapsulation efficiency as well as swelling index for all the probiotic for all the material for the probiotic yeast strain. And here we used gum acacia, which is already available as the encapsulation commercial material, which is used for the encapsulation of probiotic strains. And here we show the significant results over the commercially available gum material. And these are all the SEM analysis for the encapsulated microcapsules. These are all the microcapsules represent the rice bran, oats bran, barley bran, finger bran, and finger millet, pearl millet, as well as gum acacia coated microcapsules for the probiotic yeast. And after treatment, after GIT simulation, we have just assessed the surface under the SEM before and after treatment, and there is no significant results found before and after. Thus, we can conclude microcapsules are stable in the GIT tolerance while the GIT treatment also. And these are all the microcapsule size based on the gum material we have tabulated here. And here also we can see oats bran gum alginate coated microcapsule were the least in size compared to other materials. Further evaluation was done for under the simulated GIT tolerance. Here we can see oats bran gum alginated coated microcapsule, this orange one. The green one is oats bran coated alginate further coated with a V protein to improve the GIT tolerance. So we have seen the maximum GIT survival, the microcapsule which is coated with V protein. in all the probiotic yeast strains, especially Lipomyces tarkei, followed by the Saccharomyces cerevisiae. The loss of cell viability also assessed during long-term storage up to the 30 days, 60 days we have assessed. Among the 5 strains, Lipomyces tarkei, Saccharomyces cerevisiae showed the least loss of viability compared to other strains. Then the mucoadhesion ability was assessed using porcine intestine. We have sprinkled the microcapsule in the porcine intestine. We have done the GIT simulation. Then we have counted the attached microcapsules. So among the 5 strains, Lipomyces showed the maximum adhesion, mucoadhesion ability on the porcine intestine. So significance of this study was the use of oats bran gum served as efficient and nutritionally rich mucoadhesive polymer bender with alginate, helped with the easy gastrointestinal transit of microencapsulated probiotic yeast under simulated conditions. Further, we have done the encapsulation using electrospinning method, because the release of probiotic is influenced by internal structure of encapsulated cell because of the specific surface area, volume, size of pores, which is having a considerable effect on the cell adhesion, growth, as well as proliferation. The size and properties of nanofibers can be designed by modifying the parameters of spinning process as well as spinning solutions using response surface methodology. For this encapsulation method, I have chosen wheat bran fiber because it stimulates the growth of gut microbiomes, also as well as it is considered as excellent probiotic carrier. It protects against colon cancer. Also, as well as I have tried with the wheat germ oil and the exopolysaccharide, which is extracted from the Lipomyces tarkei. And these are all the encapsulation materials and electrospinning parameters I have taken for the process optimization using response surface methodology to enhance the encapsulation of a probiotic yeast to improve the GIT tolerance. This is the methodology I have used in this study. This slide shows the evaluation of nano-encapsulated probiotic yeast. Here, I could say it is a probiotic microfiber because it is not in a range of nano scale. So we can call it of a microfiber. Microfiber shows 100% encapsulation efficiency and GIT tolerance after exposure of stimulated gastric intestinal juice over a period of 90 minutes. Similarly, the sustained viability was noted during long-term storage over a period of 4 months for the encapsulated cells. The maximum auto-aggregation ability of microfiber was 98% after observed at 24 hours. The co-aggregation ability was with the Salmonella as well as Staphylococcus E. coli showed about 99%. The characterization of microfiber was done using various instrument analysis. The SEM analysis showed the microfiber exhibited smooth surface and consistent diameter, and the AFM showed the linear surface topology with and it shows smooth surface at 800 nanometer scale. And the zeta potential and particle size analysis was done for the encapsulated cell. According to the Muller et al., zeta potential above plus 60 millivolt would enhance the particle stability, and here we can see it is above 98 millivolt. So the stability was more in case of a microfiber. The size distribution of profile of the microfiber also assessed. The diameter was 237 nanometer in the narrow distribution. FDR analysis showed the presence of peak which correspond to secondary, primary amide stretch, aldehyde, amides, amines, carboxylic acid, and estrus. In case of Raman spectrum, we found the peak which correspond to carbohydrate, lipid, protein in all over the peaks we can see here. Coming to the gas chromatography, wheat bran and the wheat germ oil contain various polycosanols, and here we can see presence of polycosanol peaks, which starting from 19 to 27, which correspond to henicosanol, docosanol, tricosanol, tetrocosanol, and heptacosanol. TG analysis showed the minor degradation was occurred at 150 degrees Celsius. It was the maximum loss was occurred at 200 degrees Celsius. Thus, the result indicate that probiotic microfiber was considerably thermostable in the nature. Coming to the summary of the work, in the present study, 20 yeast strains from different sources were isolated and identified at molecular level. The auto-aggregation co-aggregation ability of Lipomyces tarkei, Saccharomyces cerevisiae found to be maximum compared to other strains. EPS production by Lipomyces tarkei was found to be 2.3 gram per liter at optimized conditions, and the heteropolysaccharide composition was further characterized by NMR analysis. Probiotic yeast strains were microencapsulated with oats bran gum and further coated with whey protein found to have more efficiency, which could improve the survival of Hypomyces tarkei as well as Saccharomyces fusarium microencapsules under GIT as well as storage conditions. Further, these two probiotic yeasts were encapsulated with wheat bran fiber and the EPS along with the PVP using electrospinning technique. The encapsulated Saccharomyces publigera showed 97% and Lipomyces tarkei showed 95% JIT tolerance during the JIT simulation assay. Also, it showed smooth surface, good thermal stability, and found to be partially crystalline in nature. And further, further these two strains were taken for the further studies like in vivo analysis, which I have not shown here. So this is how the PhD study was designed, and I have done it. And these are all the publication I have done during my PhD work. And these are all the reference I have used. And thank you. I thank to Microbiology Society for giving me this opportunity for presenting my PhD work in the webinar series. Thank you, one and all.
Thank you, ma'am.
Yeah.
It was indeed an excellent presentation.
Yeah.
Thank you. Today, for some mysterious reason, I think we have low audience.
Okay.
So we are open for a Q&A session. So do we have any more questions in the audience? And also, ma'am, I would request you that please put your email address in the chat box.
Okay, yeah, sure.
Thank you, ma'am.
Yeah. I'll put here or I'll do WhatsApp.
Sorry? Yeah, here, I'm in the Zoom. So all the applicants can see, and if they have any further questions, they can reach out to you.
Okay.
Yeah. So, ma'am, as you have worked on these yeast strains, have you done anything to preserve those strains?
Yeah, I have done preservation in our college. I have done it. It was in the freezer.
Okay, so which technique you use, ma'am, for the preservation?
No, I have freeze dried the probiotic strains.
Okay.
And I did it in the. I kept it in the -80. With the glycerol method only. It's a simple preservation only I've done.
Stock method.
Yeah. Stocks only I have done.
Okay, but the work you have done is really nice. So I think you should submit those strains to MTCC or ATCC, right?
Yeah, sure.
For the authentic preservation for longer duration of time.
Yes, sir.
Yeah, ma'am. And ma'am, I would like to ask one more question.
Please.
During your PhD, were there any moments that you were, facing the maximum amount of issues, and then you overcame the issue? So, would you like to share any experience?
Like in my lab, actually, I worked under Dr. Nilanjana Mitra. Actually, she was in a biomedical department, but she was guided almost all the students in bioremediation area. So I'm the first student working on the probiotics. So it was very new in all the aspect for instrumentation, all the standardization of the protocols. And I have done the cell culture work and animal work, and all the work I have done, because in our lab I'm the first student done all the work. So it was very difficult initially, but my guide was supported very much. So it was happened in stepwise. We have done everything. In case of animal work only, I faced more difficulties, like ethical committee approval we need to get before doing the work. So I'm the first person. I think in our institute, probiotic work in vivo using a yeast, I'm the first person. Bacteria people are doing, so they are not giving approval in the first year. When I applied, they didn't approve. They told me to do the pilot study. Then 6 months was gone like that. Pilot study I finished in a month. So I waited another semester for ethical clearance. So that period, it was really, I didn't, it was wasted, I could say like that. So that period I utilized for the paper writing or the publication work I have done. But still, I could have get the degree in the 2021 itself if I got the clearance uh, on time. So that is the only problem I face. The ethical clearance will be the issue. If it is a very new work, if it is nobody has done earlier in the ethical committee, so we have to do some pilot study. Then only they will approve the exact experiment we can carry. After the approval, only they will approve.
Right,
So
right, ma'am. This kind of
okay.
issues, I mean, we face it very often, right?
Yeah, yeah.
We can always learn from these experiences.
Yes, and we have to give more reports. We have to justify why we are asking this many animals, why we are ingesting this study. We have to be very steady because they will ask many questions. We have to be steady and we have to be clear in vivo analysis.
Yes, yes. Recently, I mean, just past month, we had 2 animal studies here. So I was in the committee. So I
Okay.
know it's a very rigorous process.
Yeah. If we
Thank
missed once, then again next semester only we'll get the opportunity.
correct, correct, correct.
Yeah, in some cases, in some institutes, only they'll conduct. In that case, it is very difficult. We'll miss 1 year, then next year only we will get the opportunity.
Oh, right.
Yeah.
Thank you very much, ma'am. It was indeed a very nice presentation.
Yeah. Thank you.
You carried it very nicely.
Yeah.
And one more thing I would like to mention once again,
Yeah.
that on behalf of Microbiology Society, we are providing mementos and certificate to each and
Okay.
every speaker.
Okay.
And I will be distributing mementos very soon. I think you might expect it this month.
Okay.
And certificate I will issue online.
Yeah. 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 Sure.
Maheshwari sir, hello. Am I audible, sir? Are you there? Maheshwari sir is our next speaker
Okay.
for next Sunday.
Hello, sir.
Hello, sir. Good morning.
Sir, actually,
Oh, yeah.
yes, sir. Good morning. Good morning to everyone here.
Good morning. Good morning.
Yes, sir.
So I might not be there for next Sunday. Actually, I'm moving abroad, so Deshmukh sir will be giving this responsibility to someone else. But I am your resource person, and I will provide you all the information you may need.
Yes, sir.
Okay, okay, okay. Thank you, thank you.
Yes, sure, sir. And thank you, Lakshmi, ma'am, for your speech. Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you. Thank you, sir. Thank you once again.
Thank you. So thank you one and all for being here. We will meet next Sunday. And also Microbiology Society India has one more lecture at 2 o'clock today.
Okay.
So please attend it. Okay. See you all. Thank you.
Thank you.
We'll end the session now.
Yes, sir.
Thank you.